Hello everyone, I am Mary Swarna Latha, working as an assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss the topics of total probability and Bayes theorem. So what is total probability? The total probability theorem states that if an event A has occurred and sample space S, and we cannot predict the probability of that event, then to calculate the probability of that event, the known probabilities of the events, you can calculate the probability of the event A. So that is called as total probability. If the probability of an event is unknown, then you can calculate the probability of that event with the known probabilities. It is called as total probability. So if let us say that A is an event defined in the sample space S, then let us say this is a sample space S. So on this sample space S, I am defining the event A. Now I am defining n mutually exclusive events B1, B2, B3 and so on Bn. I am defining n mutually exclusive events B1, B2, B3 and so on up to Bn. Now the probability of this event A can be defined the probabilities of the conditional probabilities of the events B1, B2, B3 and so on Bn. It is called as a total probability. The total probability of the event is expressed as P of A is equals to sigma n equals to 1 to n P of A by Bn into P of Bn, where P of A by Bn is a conditional probability of the event A and given the conditional event is Bn. And P of Bn is the probability of the mutually exclusive events Bn. Now, so let us consider this is a sample space S. So on this sample space S, you are defining n mutually exclusive events. Here B1, B2 and so on Bn are called as the n mutually exclusive events. And we have to consider one more condition. The union of these n mutually exclusive events is equals to the sample space S. That is nothing but B1 union, B2 union and so on. Bn is equals to S. So the union of these n mutually exclusive events defined in the sample space S is equals to the sample space S. Now on this sample space I am defining an event A. Now I want to calculate the probability of this event A. Then how can I calculate? I can calculate the probability of this event in terms of the conditional probabilities of the events B1, B2 and so on Bn. It is called as the total probability. Let us prove this total probability theorem. How do you prove that? You have to consider a sample space S, and this sample space S you have to define n mutually exclusive events B1, B2 and so on Bn, and then you have to consider the union of these n mutually exclusive events is equal to the sample space S. After that, you have to define event and the sample space S. Now, how can you write the event A? How can I write as in terms of what? A intersection S. For example, my experiment is tossing a die. So when I toss a die, the sample space for this is 1, 2, 3, 4, 5, 6. This is a sample space when I toss a dice. Now, I am defining one event A. So, I am defining the event A is as getting an even number. So, what are the even numbers out of this sample space? 2, 4, 6. So, this is a event. I am defining the sample space S. Now, what is A intersection S here? A is nothing but 2, 4, 6. And what is S equals to 1, 2, 3, 4, 5, 6. So, A intersection S is nothing but it is a set of the common elements. In this, the common elements are 2, 4, 6. So, A intersection S is called 2, 4, 6. Now, what is 2, 4, 6? That is nothing but the event A itself. Therefore, how can I write the event A as A intersection S? Any event I can write as the intersection of the sample space element. Therefore, I'm writing the event A as A intersection S. But what is S? And the sample space S, I have defined n mutually exclusive events. And the union of these n mutually exclusive events is equal to the sample space S. Therefore, substitute in this equation the sample space. Then what do you get here? A intersection. And what is S equals to? Union of n equals to 1 to n, Bn. So substitute S here in place of S. What do you have to write here? Union of n equals to 1 to n, Bn. After that, we have to use the distributive law. In order to simplify that, we are using the distributive law. Now, what is A here? In the previous slide, we have seen A is nothing but A intersection S. In the X, I have replaced by union of n equals to 1 to n, Bn. Now, I can calculate the probability of this event. What is the total probability? I have to calculate the probability of the event A, which is unknown. So, that nothing but you have to calculate P of A. Then, what is P of A equals to? P of A intersection union of n equals to 1 to n, Bn. So, what is P of A equals to? P of A intersection union of n equals to 1 to n, Bn. Now, I know the distributive law. So, what is the distributive law? The distributive law says that if you define 3 events in the sample space S, then how can I write as A intersection B union C is equals to A intersection B union A intersection C. And similarly, how can I write for the union property? A union B intersection C is equals to A union B intersection A union C. So, this is called as the distributive law of the sets. Now, the same thing here, what I'm having here, A intersection union of n equals to 1 to n, Bn. So, A intersection union of n equals to 1 to n, nothing but B1 union, B2 union and so on, Bn. Now, how I'm writing this as? What is the distributive law? A intersection B union C is equals to A intersection B union A intersection C. Then, by using distributive law, how can I write this as? A intersection B1 union. Next, what is the second one? A intersection B2, A intersection B2 union and so on. What is the last one? A intersection Bn. So, A intersection Bn. Therefore, by using the distributive law, I can write P of A intersection union of n equals to 1 to n Bn as P of union of n equals to 1 to n A intersection Bn. See here, how can I write this as? Union of n equals to 1 to n A intersection. So, B1, B2 and so on Bn. So, I can replace by Bn. So, union of n equals to 1 to n A intersection Bn. Therefore, I am writing A intersection union of n equals to 1 to n Bn is equals to union of n equals to 1 to n A intersection Bn. Therefore, by using distributive law, I have replaced this term by union of n equals to 1 to n A intersection Bn. Now, after writing this, I have to apply the third axiom of the probability. What is the third axiom of the probability? If you are having n mutually exclusive events, A1, A2 and so on, An. So, these are n mutually exclusive events. Now, the third axiom of the probability states that the probability of union of these n mutually exclusive events. Here, U represents what? The union. The probability of union of n mutually exclusive events is equal to the sum of the probabilities of, sum is nothing but I have to write sigma. So, sum of the probabilities of the individual events. It is nothing but P of An. So, this is the third axiom of the probability. So, by using this third axiom of the probability, I can write the probability of union of n equals to 1 to n A intersection Bn. I can write this as, so in place of An, what I'm having here, I'm having A intersection Bn. So, in place of An, I'm having here A intersection Bn. Then how can I write here? P of union of n equals to 1 to n A intersection Bn is equals to sigma n equals to 1 to n P of, in place of An, what I'm having here? A intersection Bn. So, replace that by using third axiom of the probability. After that, you have seen the conditional probability. So what is the conditional probability of an event P of A by B? Is called as what? Conditional probability. The probability of an event A and given the event B is nothing but conditional probability. Here P of A by Bn. And already in the previous lecture we have seen the conditional probability. So how can you write down the conditional probability of an event A and given the condition event is Bn is equal to P of A intersection Bn. So this is a joint probability by P of Bn, where P of Bn should not be equal to 0. Why I have written the condition here? P of Bn is not equal to 0. If P of Bn equals to 0, then what happens? You'll get P of A by Bn equals to infinity. But the probability maximum value is unity. That's why you have to assume the condition P of Bn is not equal to 0. Then only you can write down the conditional probability. Therefore, what is the conditional probability of the event A? And given the condition event Bn is equals to P of A intersection Bn by P of Bn. Now, from this, what is P of A intersection Bn? Cross multiply these two. So, therefore, what is P of A intersection Bn equals to P of A by Bn into P of Bn. So, P of A intersection Bn equals to P of A by Bn into P of Bn. Now, substitute this P of A intersection B in this equation. Substitute P of A intersection B in the above equation. So, you have replaced P of A intersection Bn by what? P of A by Bn into P of Bn. See here. So, what is P of A equals to sigma n equals to 1 to n? P of A intersection Bn. Now, replace this P of A intersection Bn by, in the previous case you have seen P of A by Bn into P of Bn. Now, replace, so what you are getting here? P of A by Bn into P of Bn. So, this is called as the total probability of an event A. Define in a sample space, yes. So, how can you write what is total probability theorem states that the probability of an event A is not known. Then, the probability of that event A can be calculated in terms of the conditional probabilities. In terms of the conditional probabilities. It is called as the total probability. So, this equation represents the total probability of the event A. Let us see one example and then we'll explain the total probability theorem. So, what is example here? A bag contains 5 red and 4 black balls. A second bag contains 3 red and 5 black balls. One bag is selected at random. From the selected bag, one ball is drawn. Find the probability that the ball drawn is black. So, a bag contains how many? Bag 1, I am having 2 bags. The first bag, what is the bag 1 contains? It contains 5 red balls and it contains 4 black balls. And a second bag contains 3 red and 5 black balls. So, one more bag. So, what does it contain? It contains 3 red and black balls are 5. After that, one bag is selected at random. One bag is selected at random. So, from the selected bag, one ball is drawn. We don't know which bag have been selected. So, I am selecting the bag randomly. So, find the probability that the ball drawn is black. So, it means you have to use which property? You have to use a total probability in order to calculate the probability of drawing the black color ball. Why you have to use a total probability? Because I don't know from which bag I am selecting the ball. It means I have to consider by selecting bag 1 as one event, selecting bag 2 as one more event. So, what is B1 I have to select? I have to define one event. So, what is one event? B1. So, what is B1? Nothing but selecting bag 1. And what is B2? Selecting bag 2. I am defining 2 events on this. So, what is the first event? B1 equals to selecting bag 1 and the second event B2 equals to selecting bag 2. So, here having only 2 bags and the union of these 2 bags. So, B1 union B2 equals to what? Yes, it means either you have to select bag 1 or bag 2. So, what is S equals to here? So, S equals to B1 comma B2. Okay, so I have to select either bag B1 or I have to select bag B2. So what is B1 union? B2 is nothing but yes only. This is bag 1 and it is bag 2. And union of this B1 union equals to B2 is equals to yes. And I'm defining one more event. What is that event? Drawing a black color ball. That is the event I'm defining. What is A equals to? This event of drawing a black ball. Now, what I have to calculate? I have to calculate the probability of drawing a black color ball. Whether I don't know it is from bag 1 or it is from bag 2. That's why you have to use here what? The total probability. Because the probability of drawing the black ball is unknown here. So, but the probability of selecting bag 1 is known. The probability of selecting bag 2 is known. And the probability of selecting black ball from bag 1 is known. And the probability of selecting black ball from bag 2 is also known. So, from all these known probabilities, we are calculating the probability of the unknown event selecting a black ball. Now, what is P of B1? So, P of B1 nothing but what? Selecting a bag 1. So, only having 2 bags. Out of 2 bags, you have to select 1 bag. Therefore, what is the probability of selecting bag B1 is equals to 1 by 2. And similarly, probability of selecting bag 2, P of B2 is equals to 1 by 2. Next, what is P of A by B1? Is nothing but what is the event A? Selecting a black ball. That is event A. And what is event B1? Selecting a bag 1. That is a event B1. Now, what is P of A by B1? Nothing but it is the probability of drawing a black ball. Probability of drawing a black ball. And given that the ball is drawn from bag 1. So, it is a conditional probability. P of A by B1. Now, can you tell me also what is the probability of drawing a black ball and given that it is from bag 1? So, what is that? Bag 1 consists of how many black balls? Totally 4 black balls. Okay, total how many balls are there? 5 plus 4 is equals to 9 balls are there. Then what is the probability of drawing black ball and given that the ball is from bag 1 is equals to what? 4 by 9 is equals to 4 by 9. And similarly, what is P of A by B2? So, P of A by B2 is nothing but probability of drawing black ball, probability of drawing black ball and given that the ball is selected from bag 2. It is called as P of A by B2. Now, what is the probability of drawing black ball and given that the ball is drawn from bag 2 is equal to what? How many black balls are there in the bag 2? 5 black balls. And totally how many balls are there? 8 balls are there. So, out of 8, 5 balls you have to select. Out of totally you are having 8 balls and the number of favorable outcomes, how many balls are there? Black balls? 5 are there. Then what is the probability of selecting black ball and it is given from bag 2 is equals to 5 by 8. So, it is nothing but 5 by 8. Now, I have written the probability of selecting bag 1, the probability of selecting bag 2. After that, I have written the probability of selecting black ball and it is given from bag 1. And I have written the probability of selecting black ball and given that the ball is drawn from bag 2. I have defined all these probabilities. Now, what I have to calculate? I have to calculate the probability of drawing a black ball. Either it is from either bag 1 or bag 2, I don't know that. It is unknown event. So, then you have to use the total probability theorem. Then how can I find P of A is equals to? So, this is a total probability theorem. Sigma n equals to 1 to n P of A by Bn into P of Bn. Here, how many events are here? What is capital N? You are having only 2 mutually exclusive events. Therefore, what is capital N equals to 2 here. So, if I expand, what I am going to get here? P of A is equals to sigma n equals to 1 to 2 P of A by Bn into P of Bn. So, this is a probability of the event drawing a black ball. So, therefore, what is P of A equals to here? Expand this one. So, what you are going to get here? P of A by B1 into P of B1 plus P of A by B2 into P of B2. So, already we have written P of A by B1. What is the value? It is 4 by 9. P of A by B2 is 5 by 8. P of B1 is 1 by 2, P of B2 is 1 by 2. Substitute all these values in this formula. Then you can calculate the probability of drawing a black ball from any bag. I don't know which bag I'm selecting, but I can calculate the probability of drawing a black ball. That is equals to what? 77 by 144. This is the answer you're going to get. Therefore, you can calculate the probability of any unknown event from the probabilities of known events. It is called as the total probability. And one more example I'm defining here. What is example here? In a class, 60% of the students are boys and the remaining are girls. So, for example, the class consists of 100 students. Out of 100, how many boy students are there? 60%, nothing but 60 members are boy students. And remaining, how many are there? 100 minus 60 is equals to 40. So, 40 students are girls and 60 students are boys. After that, what they have given? It is known that the probability of a boy getting distinction is 0.3 and the probability of a girl getting distinction is 0.35. Find the probability that a student chosen at random will get distinction. So, what they have given? They have given that the probability of a boy getting distinction, so, is equals to what? 0.3. And what is the probability of girl getting distinction is 0.35. What I have to calculate? I have to calculate the probability of a student. A student is chosen random. I don't know is the student is either boy student or girl student. I don't know, it is random. But what I want to calculate the probability of the student getting the distinction. It means I don't know the student may be boy or girl. It means how to use it is unknown event. How to use the total probability theorem. So, in order to calculate this theorem, in order to calculate the probability of this event, I have to use the total probability theorem. Now, let us define the events. What is event B1? Selecting a boy. Selecting a boy is the event B1. And selecting a girl student is nothing but event B2. Then, what is B1 union B2 equals to the sample space? Nothing but what is sample space here? Boy and girl is a sample space. And what is B1? Selecting a boy student. And what is B2? Selecting a girl student. And what is B1 union B2 equals to yes. And what is B1 intersection B2? I have to, in order to use the total probability, one more condition is there should be n mutually exclusive events. The event should be mutually exclusive. Here, B1 intersection B2 is nothing but pi, because if I select the boy student, there is no chance of selecting the girl student. Therefore, B1 and the event B2 are mutually exclusive events. So, what is P of B1? 60%. Because what is B1? Selecting a boy student. How many are here? 60. So, 60 by 100, nothing but what? 0.6. Next, what is P of B2? Selecting girl student. How many girl students are here? 40 are there out of 100. Therefore, what is the probability of selecting girl student is 40 by 100. That equals to 0.4. Next, what I'm defining one event A. What is the event A? A is nothing but getting the student as distinction. That is the event A. How can I define the event A as? The student is getting distinction. Nothing but event A. Now, what is P of A by Bn? Nothing but the probability of getting the distinction, probability of getting the student as distinction, and given that the student is a boy. What is P of A by Bn? The probability of getting the student as distinction, and given that the student is a boy. Then what they have given here? They have given it is 0.3. So write down here 0.3. And similarly, what is P of A by 2? So what is P of A by B2? It is conditional probability. That is nothing but the probability of the student is getting the distinction, and given that the student is a girl student. What is P of A by B2? The probability of getting the student as distinction, and given that the student is girl student. So what is the probability of selecting the what is the probability of getting the distinction of girl student is what? 0.35. So write down this as 0.35. Now what I have to calculate here? I have to calculate the probability of the student is getting distinction. I don't know the student is boy student or girl student, but I want to calculate the probability of getting the student is distinction. Then how to calculate P of A. So in order to calculate that, I have to use a total probability theorem. So what is the total probability theorem? P of A is equals to sigma n equals to 1 to n P of A by Bn into P of Bn. So this is a total probability theorem. Here, how many events are here? What is capital N equals to 2? So these two are starting boy student, girl student. Only two mutually exclusive events, B1 and B2. Therefore, what is N equals to 2? So if you expand this equation, then what do you get? P of A equals to P of A by B1 into P of B1 plus P of A by B2 into P of B2. Now substitute all these values and then calculate the probability of getting the student as distinction. So like that, I can apply the total probability theorem in real life applications. And the next concept is Bayes theorem. So what is the Bayes theorem? Let the B1, B2, B3 and so on Bn are n mutually exclusive events defined in the sample space S, and you are defining an event A and the sample space S. If you want to calculate the probability of the event Bn and given the conditioning event is A, then you have to use the Bayes theorem. Then what is P of Bn by A equals to P of A by Bn into P of Bn by sigma n equals to 1 to n P of A by Bn into P of Bn. So this is nothing but what is sigma n equals to 1 to n P of A by Bn and P of Bn already have seen. So it is nothing but the total probability P of A. So this is a Bayes theorem. Now let us prove this Bayes theorem. Okay, so what is P of Bn by A is equals to P of A intersection Bn by P of A. So from this, what is P of A intersection Bn is equals to P of Bn by A into P of A. Now similarly, what is P of A by Bn is equals to P of A intersection Bn by P of Bn. So from this equation, what is the joint probability P of A intersection Bn equals to P of A by Bn into P of Bn. So let us say this is equation 1. Now substitute P of A intersection Bn in equation 1. So what is equation 1 here? P of Bn by A. So P of Bn by A is equals to P of A intersection B. I have to replace the P of A intersection B by what? P of A by Bn into P of Bn. So substitute here. So replace P of A intersection B by P of A by Bn into P of Bn by, so by what I am having here? Okay, so what I am having here? By P of A. So substitute here P of A. So this is called as what? Total probability. So what is total probability? The probability of the event Bn and given the conditioning event is A is equals to what? P of A by Bn into P of Bn by P of A. So from total probability theorem, what is P of A? You have to replace P of A because already have seen the total probability theorem in the previous topic. So what is P of A is equals to sigma n equals to 1 to n P of A by Bn into P of Bn. So this is called as what? Bayes theorem. So this is called as Bayes theorem. So what is Bayes theorem? If B1, B2, B3 and so on Bn are n mutually exclusive events, then the conditional probability of the event Bn and given the conditioning event A is equals to P of A by Bn into P of Bn by P of A. What is P of A? Sigma n equals to 1 to n P of A by Bn into P of Bn. So this is called as a Bayes theorem, which is most important to calculate the probabilities. Let us explain this base theorem with an example. So what is example here? In a bolt factory, machines A, B and C manufacture 25, 35 and 40% of the total bolts respectively. Of their outputs, 5, 4 and 2% respectively are defective bolts. A bolt is drawn at random and found to be defective. What is the probability that the bolt came from machines A, B and C? So in the factory, let us say this is a factory. So the factory consists of how many machines? It consists of 3 machines, machine A, B, C. Okay. And let us say the total it is producing 100% or 100. So what is mission A is producing out of that 25% and mission B is producing 35 and mission C is producing 40. So 25 plus 35 is 60, 60 plus 40 is 100. Okay. Now of their outputs, 5, 4 and 2% respectively are defective bolts. It means, so in the from mission A, out of 25%, how many are defective? 5% are defective. Mission B, 4% are defective. Mission C, 2% are defective. Now, a bolt is drawn at random and found to be defective. It means randomly they have selected bolt. But I don't know the bolt is from which mission, either it is from mission A, mission B or mission C. Okay, bolt is drawn at random and found to be defective. So what is the probability that the bolt came from missions A, B and C? Nothing but what you have to do here first, you have to consider what? You have to consider 3 mutually exclusive events. What is B1? B1 is nothing but selecting mission A. And what is event B2? Selecting mission B. And what is event B3? Selecting mission C. So I am defining 3 mutually exclusive events B1, B2, B3 and that is nothing but B1 is selecting a mission A from the factory and the event B2 is selecting a mission B from the factory and B3 is selecting a mission C from the factory. Now what is P of B1? The probability of selecting mission A from the factory. Totally how many missions are there? 3. Out of that I have to select 1 mission. Therefore what is P of B1? But what is the probability also they have given? It is manufacturing in terms of percentages. Only 20 out of 100%. Mission A is producing 25%. Mission B is producing 35% and mission C is producing 40%. It means mission C is having more probability. Mission B is next and mission A is having the least probability. Then what is P of B1 equals to 25 by 100 and P of B2 equals to 35 by 100 and P of B3 equals to 40 by 100. Next, what is P of? Let us define the event A. What is the event A? Nothing but selecting a defective bolt. That is the event A. Now, what is P of A by B1? It is a probability that selecting a defective bolt and given that the bolt has been selected from mission A. So, what they have given in the problem? They have given it as 5%. Then what is P of A by B1 equals to 5% is nothing but 5 by 100 that equals to 0.05. And similarly, what is P of A by B2? The probability of selecting defective bolt and given that the bolt has been selected from mission B. So what they have given in the problem? Nothing but 4%. So 4% nothing but 4 by 100 that equals to 0.04. And similarly, what is P of A by B3? The probability of selecting a defective bolt and given that the bolt is selected from mission C. So what they have given? They have given it as 2%. So 0.02. 2 by 100 nothing but 0.02. Now what I have to calculate? I have to calculate the probability that the bolt came from mission A. First I am calculating from mission A. Similarly I can calculate the probability from mission B and similarly mission C. Okay. Then so what is the probability from mission A is equals to P of B1 by A. So is equals to P of A by B1 using base theorem you have to apply here. P of A by B1 into P of Bn by P of A by B1 into P of B1 plus P of A by B2 into P of B2 plus P of A by B3 into P of B3. It means I have to apply Bayes theorem. What is the Bayes theorem here? So this is a Bayes theorem. In this, what is how many events here? 3 events. So 1, 2, 3. What is Kaplan value? 3. So up to 3 I have to take here. Okay. And here what is first event here? I want to calculate P of B1 by A. So replace Bn by B1. Then write down P of B1 by A. The probability of selecting the mission A and given that it is a defective bolt is equals to, this is a formula. Now already you have written all the probabilities, substitute these values and calculate P of B1 by A. And similarly, P of B2 by A. What is P of B2 by A? The probability of selecting the bolt from mission B2 and given that the bolt is defective. That nothing but P of B2 by A. So from Bayes theorem, you can write down this formula. So what is P of B2 by A? You can write as P of A by B2 into P of B2 by P of A. What is P of A? Nothing but P of A by B1 into P of B1 plus P of A by B2 into P of B2 plus P of A by B3 into P of B3. So substitute all these values and calculate P of B2 by A. And similarly, I can calculate the probability of selecting the bolt from mission C and given that the bolt is defective. That is nothing but P of B3 by A. So this is a formula using the Bayes theorem. By substituting all the values, I am going to get this answer. So like that, you can apply the Bayes theorem in the real life applications to find out the probabilities. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.